Okay, so this video is going to be on Unit 8b, and the first question is another one that deals with one of these right triangles, a big right triangle here, that's been chopped from the right angle into two smaller right triangles, one here, one there. So let's take a look at this. Now the general strategy is to draw the three triangles by themselves. So here's the big one, D, E, G. And then here's one of the smaller ones, the one on the left. So D, F, E. And then the one next to it that's a little bit bigger. So this one is F, E, and G. And then there would be a right angle there too. So we already have all the right angles matched up. And then if I go back to the big one, and I mark one of the angles with a curve and the other one with two curves, then, well, angle D is reflexive with this angle D right there, and angle G is reflexive with this angle right here. So then so this triangle has a one curve, a two curve, and a right angle. This one in the middle has a one curve and a right angle, so it's missing two. And then this one is missing a one. So when I labeled one of the triangles DEF, that's this triangle, and it goes D to E to F. That's one curve, two curve, right angle. So if I do that with the other ones, that'd be DGE, one curve, two curve, right angle. And let's see, one curve, two curve, right angle, EGF. Right there. Okay, so that's number one. Number two is simplifying roots. So what I tend to do is I tend to look for nice, so like root 12, you could do root 2 times root 6. I try to generally look for stuff like root 4, root 9, root 16, because these are nice numbers. These actually turn out to be 2, 3, and 4. If you can find a root 25, that'd be 5, and so on. So for root 12, one of the things that works is it's root 4 times root 3, and root 4 is a nice number, that's just 2. So this turns out to be 2 root 3. Root 72, well, that one's a little bit trickier. You might think of 8 times 9, so root 8 times root 9. Well, root 9 is really just 3. So this is the same as root 8 times 3, or 3 root 8. But then you don't want to stop there, because root 8 you can actually simplify. That's going to be, there's still the 3 in front, and 8 is the same as 4 times 2, so root 4 times root 2. And root 4 is really 2. So this would be 3 times 2 times root 2, which is 3 times 2 is 6, and then there's a root 2 there. Okay, let's look at 9 root 40. So the 9 is on the outside, so I'm not going to simplify that because that's just 9. Root 40, well, you might think of like root 4 times root 10. Well, this is 2, so it's 9 times 2 times root 10, which is 18 times root 10. And root 10 is root 2 times root 5. You can't do anything with that, so you would just leave it like this. And then root 30 times root 6, you could multiply them together and get root 180 and then try to simplify root 180. But you could also just break down what you have here. Like root 30 is, let's say, root 3 times root 10. And then root 6 is root 2 times root 3. And no, I got a root 3 and another root 3. Well, root 3 times root 3 is 3. So I got a root 3 and then a root 10 and a root 2. And we can break down root 10. So root 10 is root 2 times root 5. And then there's still that other root 2 at the end. Well, this times this, root 2 times root 2 is root 4, or regular 2. So I've got a 3. And then these root 2's become a regular 2. And then there's root 5 here. So this ends up being 6 root 5. Now there's another way to do this also. Maybe, whoops, sorry. Maybe you notice root 30 is the same as root 6 times root 5, and then times this root 6. Well, root 6 times root 6 is regular 6, so this is going to be 6 root 5. Let's take a look at the next one. So in number 3, we got a right triangle, and all 3 sides are labeled, and there's only one variable. And so the only thing that I could really do with a right triangle is set up Pythag. So let's do that. So we've got x squared plus, and then I want to square all of x plus 3, so I need to put it in parentheses. And then that equals the hypotenuse squared. So that's going to be x squared plus, and then I'm going to write this out like this. X plus 3 times x plus 3 equals, and then 10 squared is 100. So this will be x squared plus, and then don't forget you have to FOIL this. It's not just x squared plus 9. It's the first terms, x squared, plus the outer terms, 3x, plus the inner terms, 3x, plus the last terms, 9, equals 100. So the 2x squareds put together is 2 times x squared plus 6x and plus 9 equals 100. And then if I subtract 100, I get 2x squared plus 6x minus 91 equals 0. And then at this point, we can use quadratic formula. A is 2, B is 6, C is negative 91. And if I plug into the quadratic formula, b squared minus 4ac all over 2a. Let me call up the calculator here. Okay. So I'll store my letters. Let's see. 2 store as A. And 6 store as B. Whoops. B. And negative 91 store as C. And so then I'll get my fraction by doing alpha f1, numerator over denominator, negative b plus the square root of b squared minus 4ac all over 2a. And so we get 5.410. Or if we do the negative version, so let me come back up here, and then I will choose the negative version. So I'll just switch the plus to a minus. I get negative 8.410. But notice one of the sides is x. I can't have a negative for the length. So the only answer is really this one. Okay. In the second diagram, it turns out that a good hint is to use auxiliary lines or extending existing lines. Really, typically you want to draw lines that are parallel or perpendicular to ones that you already have. And the hint that I've been giving people in class is see if you can make a rectangle somewhere. So you could try slicing it right along here with the line parallel to this guy and making a rectangle out of this shape on the bottom here. Well, if it's a rectangle, then the top of the rectangle is x, and this side should be the same as that side. So this part's 20, and this part is 10. So if you notice up here on top, this is a right triangle. So I can do x squared plus 10 squared equals 42 squared. Well, that's x squared plus 100 equals, what is that, 17 something or other. Let me check. 42 squared. That's 1764. And if I subtract 100, I get 1664. And then I'll take the square root of that. And just to get a feel for what that is, it's not going to be a nice number, but let's see what it is. It's about 40.792. By the way, you could actually slice this some different ways too. For example, you could slice it, you could extend it and make this a rectangle instead. And if you did that, then the top would be x, because it's the same as this one. This part's 20, the whole thing's 30, so this would have to be 10, and then you'd be doing Pythag on the same triangle right there. Another way to do it is actually to draw a line parallel to this one from here. Whoop, sorry, right there. If I do that, then this guy's a parallelogram. So this part's 20, this part's 10, this part's 42, and then you've got the same triangle to work with, but now it's down there. Okay? All right. Let's take a look at 4. Okay, so let's take a look at 4. Sorry, I paused it for a second, so I lost track of where I was. So in this one, notice it's again one of these right triangles, big right triangle, chopped from the right angle into 2 smaller right triangles. So a lot of students think, well, let's use that theorem that we just learned, the up-down theorem. Well, in this case, you can't really use it yet because I don't know what this side or this side is. So there's 2 out of 3 things that I don't know, so you can't solve for both at the same time. But what you could do is, we know that this side's a right angle. Just take a look right here at this triangle, and it looks like this. This part's 9, this part's 6, and this part I don't know, but I don't know, I'll call it W, let's say. I can solve for W using Pythag. So if I do 6 squared plus W squared equals 9 squared, then I got 36 plus W squared equals 81. So if I subtract 36, I'll get 45. So W is going to be root 45. So in this picture, whoops, this is root 45 right there. Okay, well at this point, I can actually do the up-down thing. 6 over root 45 is the same as root 45 over this part. So I can't call that x because x is the whole thing. But this part right here is x minus the top part, 6. So I can set up that proportion with the up-down theorem. It's 6 over root 45 equals root 45 over x minus 6. Now in class, some students were asking me, do you have to go that direction? Could you do x minus 6 over root 45 equals root 45 over 6? And yes, you can do that too. The one that you can't do is you can't go this way like that. 9 over root 45 is not the same as root 45 over y. The up-down idea that we've been using has to come starting with this side over here, right, with the hypotenuse of the big triangle. Okay, so let's work this out. If I cross multiply, that's going to be root 45 times root 45, which is regular 45. So now I got 6x minus 36 equals 45. 6x is going to be 81. Is that right? 45 plus 36 is 81, yeah. And then x, x will be, oh, I lost my marker. X will be 81 over 6, which is 13.5. So that's x, 13.5 here. So then the question is, well, how do we get y? You can do it a bunch of ways. You could do root 45 squared plus 13.5 minus 6 squared equals y squared, because that's a right triangle. But I think an easier one to use would be the whole big triangle here. This is 9, this is y, and x is the whole length here, which is 13.5. So we could set up now 9 squared plus y squared equals 13.5 squared. So it's 81 plus y squared equals, I don't know, what's 13? Well, let me restart this. Clear. 13.5 squared is 182.25, and then we'll subtract 81. So y squared is 101.25, and then that means y is going to be the square root of that, which is 10.062 roughly, or root 101.25. Okay, so number 5 says show that this thing's a right triangle. Well, the easiest way to do that is to look at slopes. So if I figure out the slope of BC here, I'm going up 1, 2, 3, 4, and over 1, 2, 3, 4. So it's rise over run, 4 over 4. The slope of BC is 4 over 4, which is 1 over 1. And the slope of BA, 1, 2, 1, 2. Slope of BA is going to be 2 over 2, but notice it's downhill, so it's actually negative. And the slopes here of BA and BC, they're negative reciprocals. So that means that BA is perpendicular to BC, and that means that triangle ABC is a right triangle. Okay. Number 6 says explain a second way of showing that ABC is a right triangle. So what you could do instead, I'll actually prove it, not just explain it. 1, 2, 3, 4, 5, 6, and 2 right here. You could use all the slope triangles to get the 3 sides here. Not the slopes themselves, but the actual lengths. So like 4 squared plus 4 squared equals BC squared. And then if you solve that, you'll get BC equals root 32. And then if we did it with BA, you got 2 squared plus 2 squared equals BA squared. So that's going to be 4 plus 4, and then you take the square root, you get root 8 is BA. And then if we did it with AC, you got 2 squared plus 6 squared equals AC squared. And that's 4 plus 36, and then you take the square root, you get root 40 is AC. And then you check, do these 3 sides form a right triangle? So here's BC, root 32, BA is root 8, and AC is root 40. So we'll plug those guys into Pythag. And the longest side's root 40, so that's going to be the C. So we're checking is root 8 squared plus root 32 squared. Is that the same thing as root 40 squared? Well, root 8 squared is 8. Root 32 squared is 32. And root 40 squared is 40. And 8 plus 32 is 40. So since the sides work in Pythag, triangle ABC is a right triangle. Okay, so I hope that helps a little bit, and I'll see you guys soon.